Let's attempt this DSE mathematics questions on three-dimensional problem. This is taken from the year 2020. So it started with a random, irregular quadrilateral, right? But the question gives you a lot of information about that quadrilateral. Now I put them at the respective positions, right? We have 60 cm and 40 cm, and then you have three angles. But then we can split the 120 degrees, right? Because you can use angle sum of triangle to discover that this angle is indeed 95 degrees. So the other angle here will be 25. Alright, we can split the 120 degrees in this way. Alright, because using angle sum of triangle, we can get the 95 and hence the 25. Alright. So part A, we want to find the length of RS, right? We want to find the length of this line. But then in this focus triangle, we only get two pieces of information. We know the 25 degrees, we know the 40. So the plan is to get the dotted line PR. In this triangle, we can use ASA. We have ASA to get the line PR. With PR, then we can use SAS in this triangle to get RS. That is the plan, alright? So let's carry out the plan. First of all, we use ASA in triangle, what's that, PQR. Alright, so that we have the distance of PR will be 60 divided by sine 55 degrees and multiply to sine 30 degrees, right? That is the length of PR. And my calculation goes to 36.6232, alright? So this one is 36.6232. Maybe it will be useful later on. And then we can furthermore, we can use ASA in triangle PRS, alright, in this triangle. Now that we have PR, so we can use ASA cosine formula. You can do it on the calculator. It is formula 02. So right away, we have RS equals to 16.9088. Right, this is the length of RS, right? So that will score you 3 marks for finding the length of RS. The plan is to get the red 95 and the 25 degrees, and then we can use ASA sine formula in PQR to get the length of PR, the dotted line. With PR, we shift to the triangle on the right, right? We use triangle PRS to invoke SAS cosine formula to get the length of RS. Right, this is it. And then for the area of the paper card, you can consider the two triangles separately. Alright, you can have the area equals to half. Alright, the area will be half 60 times PR times sine 95 degrees. This is the triangle PQR. Alright. And then add to it, we have 40 times PR times 25 degrees. That is the triangle PRS. Alright, so altogether, we add up the area will be 1404 cm square. Right, this is the answer to part B. Alright. Now part A and B, they are not difficult in this question. They just set up the scene for the more difficult part later on. And most of the thing, all of the thing in part A and B, they are only two-dimensional. Alright. So anyway, this is how we did part A and part B. Now let's take the next challenge and look at part C. Alright. Part C says that the angle between the paper card and the horizontal ground is 32 degrees. Alright. So now where is the angle between the cardboard and the ground level? So I draw the diagram here, right? To find the angle between two planes, first of all, we get the common line. The common line between the cardboard and the ground is this purple line QR here. That is the common line, am I right? Between the cardboard and the ground level. This purple line is the common line. So on the common line, we draw perpendicular, right? We draw the perpendicular like the gray one, right? It's perpendicular to the purple line. Also, we can draw the blue one that is perpendicular to the purple line as well. Alright. And the shortest distance from P to the ground level will be this H, will be this dotted distance, right, behind the cardboard. Alright, so if you can get the blue line, then you can use sine ratio to get H. Alright, so simply H will be the blue line times 32 degrees. Let's call it A, alright? Will be A times sine 32 degrees, alright? That is how we get H. But how do you get the blue line? The blue line, you can look at the PQR triangle, I suppose, alright? You can look at the PQR triangle. We have P, R, Q, alright? The rest of the triangle will be like this, but I don't care. Alright, we can have S and R like this, right? RS is the red line. The cardboard is like this, right? But all we want to know is this blue line. The blue line is where point P goes perpendicular to QR. In addition, we know that this is 60, this is 30, right? So the blue line is not difficult. The blue line is just 60 times sine 30. Alright, the blue line is just 60 degrees times sine 30. Alright, so that is, you're putting this all together, we have the H. We have the H, alright? H will be 15.9, alright, cm. Alright, does it make sense? Alright, perhaps, alright, because the angle is quite small, so H is about 16 is, making sense. Alright, so that is part C1. The height of point P above the ground level. Alright, so first we look at the common line, and then from the common line we draw the blue line that is perpendicular to the purple. And then we draw the gray line on the ground that is also perpendicular to the purple. Alright. And we know that the angle between the blue and the gray is 32 degrees. So we can use simple sine ratio to get H. But we also have to get the blue line A. The blue line we can find it on the paper card, on the PQRS, on the card itself. Alright. We can get that. Alright. So this is it about the point about the part C1. Alright. Now the difficult part is part C2, I guess. Alright, part C2, let's move to another page. We want to find the a student claims that the angle between RS and the horizontal ground is at most 20 degrees. So she is referring to this angle, alright? She said that this angle is at most 20. So the first question that pops up is that, isn't this angle 32? Because you just said that the angle between the cardboard and the ground level is 32 degrees, right? So isn't that angle 32 degrees, right? It turns out it is not 32 degrees, as you can see from the diagram here. The red line and the blue line, they are not parallel. So what are 32 degrees? If you draw another orange line that is parallel to the blue, alright? That in other words, that is perpendicular to the common line. I use the purple line to indicate the common line, right? If you have an orange line, right, that is perpendicular to the common line, or in other words, is parallel to the blue line, then the angle that it makes with the ground is 32 degrees, alright? Or if you have any other line that goes parallel with the blue, then the angle they make with the horizontal is 32 degrees. However, the red line is not perpendicular, is not parallel to the green line, to the blue line, isn't it? Alright, we can look at the cardboard from another angle. If you look at the cardboard here, PQRS, alright, it is something like this, isn't it? Alright, if the blue line is something being here, alright, that is the blue line. We have the PQRS, alright. We did all the calculation. We know the length of PR, we know every angle, we know every line, alright? So I guess it's not difficult to figure out that this is not a right angle. In fact, you can work out the calculation, right? We already, from the given, we know that this is 55 degrees over here, right? So it is 55 degrees right here. It's 55 degrees. So what is this orange one? Alright, for this orange one, you can use the triple S cosine formula, right? PS is 40 is given. RS is the red line, we just did that, is 16.91, something like that, alright? and then PR will be the gray line. The gray line will be 36.6232, right? We did that in part A. So we can use triple S cosine formula to find this orange angle. My calculation shows that this angle, let me see, it is 88.7431. Alright, using triple S cosine formula, sorry, wrong color. Using triple S cosine formula, you obtain this orange angle to be something like this, right? So the entire angle here is definitely not a right angle. It turns out 88 something plus 55 degrees is much greater than a right angle. It's 143.7431 degrees. All right, the whole angle R is something like this. All right. So now we know the angle here. Let's call it theta. Right? Theta is not 32 degrees. So what is it? It is definitely smaller than 32, but the student claims that it is at most 20. So how correct she is, all right? So how do you find this theta angle? We have the we have the red line. The red line is 16.9088, right? We have the red line like this. We need one more piece of information in this triangle, right? We know the 90 degrees. We know the red line, all right? So our target is to find the green line. We know sine theta will be the green line divided by the red. Sine theta will be the green line divided by 16.9088, alright? If we can find the length of the green line, then we can find theta. Alright, so that we have theta equals to something. And we can compare it to 20. Alright. So how do you find the green line? In other words, how to find out how far is point S from the ground level? What is the height of point S? Alright, what is the height of the point S? So we can mimic what we did in the blue line. Alright, if you extend this common line here, the common line was purple. If you extend the common line, if you want to find the height of S, if you want to find this, let's call it D, alright, it's very similar to how we find H. Alright, we draw a common line. I put it in red dotted line, a blue dotted line, alright? We draw the blue line that is also parallel to the original blue line. In other words, it is perpendicular to the purple line, right? And then this angle will be 32 degrees, isn't it? Because this is also a right angle. Alright, and this angle will be 32 degrees, isn't it? The blue line here, let me switch to solid line, alright? The blue line here is parallel to the original blue line. Alright, these two blue lines, they have different length, but they are parallel. So the angle between the blue and the gray is always 32. Now, if you can find the blue line, then you can find the length of D. With D, you can find theta. So how do we find the blue line? We can find the blue line from this blue, red, purple triangle. This is the final piece of the puzzle. We can find the blue line, right, from this red, blue, purple triangle. Alright, we know that this is right angle, this is S, this is R. Now never mind this point, let's call it Y, alright? Let's call it point Y. This is point X, alright? Can you see how, why is it so? Because we know this angle is 143 something, right? So we know that the supplementary angle will be 180 minus this one. So this is 36.2569. Alright, this angle is 36.2569. Alright, knowing that the red line is 16.9088, so you can use sine ratio to get the blue line. My calculation shows that the blue line is 10.00. It's almost very close to 10. Alright. So with the blue line and the green line and the 32 degrees, we can find the length of the green line. The green line is the height of point S above the ground level. Alright. So this is S, this is Y, right? And that is the length D. we know that this angle is 32 degrees. If the blue line is kind of like 10.00, we obtain D. Alright? The answer of D, according to my calculation, what is D? Is about 5.299. Alright? So that is the whole story. Alright? First of all, you have to identify the angle. The angle theta is the one here. You want to compare this one greater than or smaller than 20 degrees. But how do you find this theta, right? You know that all the blue lines, they are making the angle 32 degrees with the ground level. All the blue lines, I mean, all the blue lines that are parallel to the original blue line, alright, as long as they are perpendicular to the purple line, the common line, then they are making 32 degrees with the ground level. Alright, so through point S, we draw another blue line passing through point S, and that's where we recover the 32 degrees. If we find the length of the SY blue line, if we can find the length of the SY blue line, we can make use of the 32 degrees to get D. With D and the red line, we can find theta. My calculation shows theta to be 18.26 degrees. So it is less than 20 degrees. So the claim is correct. Alright, because it is less than 20 degrees. It is at most 20 degrees. Alright, so this is how we calculate the final part in this problem.